So continuing from the last part, now let us see the other type of problems with this problem is a 3 variable K-map problem, but in the POS form. So the previous problem which we have seen was in the SOP form. So this problem we will see in the POS, this product of sum form. So let's say the question is that we have to simplify this function, which is a 3 variable function, and the function now given is as pi. Okay, so pi is this particular symbol is for your POS max terms. Okay, so max terms, so product of max terms, so pi is for product. So product of max terms, the max terms are present are 0, 1, 2 and 4. Okay, so using the K-map we have to simplify it. So what we will do is, okay, so let's see how we'll do. So rather than filling up the K-map, because again we have to draw the K-map, so we'll see that it is a the maximum decimal number which is present in the function is 4. So 2 to the power 2 if we do, so it will be 4 although, but it will come up to 3, 0, 1, 2, 3, but the term is 4. Okay, 4 is coming. So then the number of variables which we have to choose is 3. So because 2 to the power 3 is equal to 8. So then this variables, there are 5 terms basically. Okay, so 0, 1, 2, 3, 3 is missing, so 4 is there. So the variable is going up to 4. So we have to consider the K-map up to K-map of 3 variables. So if we choose the K-map of 3 variables, then we can draw it like this. Okay, so the same as what we have done in the last question. Now these terms are this max terms. So rather than filling up the ones in the K-map, we fill up the zeros. So again these are the positions. So this is the 0 position, 1, 3, 2, 4, 5, 7 and 6. Okay, so these are the positions. The positions will remain same. Now we will fill up the this positions. So wherever this max terms are present, so wherever these max terms are present, we will fill up a 0, and then we will combine them, and then we will see that what the answer will be. So you see this can be, this is 0, so 0 is available, so 0 is filled here. Then 1, so 1 is filled up here. Then 2, so 2 position is this, so we have filled this up. 3 was this, so this is left, this is unfilled. So whichever is like nothing is returned, so unfilled squares, unfilled cells are having 1 here. Okay, so the 4 is this cell, so we have filled 0 here. Now we'll try to combine them. So the first thing which we will try is, we'll try to form the octet. So is it possible to form an octet? As all these squares are not filled up, so we cannot form an octet. Okay, so this is very clear. So if we cannot form an octet, then the next lower target will be quad. So can we form a quad, pair of a group of 4 zeros, and they should be adjacent zeros. Okay, they should be in the adjacent cells. So you can see that although these 3 cells are adjacent to each other, but this cell although is adjacent to this cell, but it is not adjacent to this. Okay, diagonally they are not adjacent, and this is not adjacent to this one, because there are 2 changes. If you see, you will find 2 changes. X is 1 and yz are 0, 0 here, whereas if in this cell you will see x is 0 and y is 1. So there are 2 changes which are taking place. Okay, similarly if you see here, you will find there are 2 changes. X is 1, x is 0 here, whereas y is 0 here and y is 0 here, so they are same, but z is 1 here and z is 0 here. So these 2 cells are not adjacent. So that is why we don't form the pairs in the diagonal. Okay, so that is what the reason is. So sometimes people have confusion that why don't we form the pairs in the diagonal. We don't form the pairs in the diagonals because the 2 cells are not adjacent to each other. That is what the reason is. Okay, now once we have filled up the entries, then let's try to solve this. So let's try to form the this. If the quads are not possible, then we have formed the pairs. So let's see the pairs. So what are the pairs? So the pairs are, see this one. So if we form this pair, so there is this one pair, so this and this cell, so they will form one pair. Okay, so this is one pair. So there will be three pairs should come. Okay, so one pair, so this particular pair is like corresponding to it. The terms which we will get is again the changing variable we will not include in the term, whereas the unchanging, the variables which are not changing should be included. And in this case, in the previous case, the complement was included as bar. Okay, but here the complement will be included as the variable itself, not the complement. And in the previous term, as we were grouping the mean terms, so we have like used a product term. Okay, so we have used z, or I mean the product term. Here, as we are using the grouping of max terms, so we write it as plus. Okay, so in this form rather than the other form. So you see, if we form this group, so the green group, if you will see, corresponding to that, the term should come as C. X is remaining same in this group, whereas Y is changing, so Y will be dropped out, and the term will be X plus Z. So X is 0 in both these cells, and Z is also 0 in these two cells. Okay, so X plus Z, not bar. Okay, right. And similarly for these two cells, the red cell, the red group, the red pair, the term will be X is changing, so X will be dropped out, and YZ, so Y plus Z, right? Then similarly for this pair, this black or blue, whatever color you can see. So this is if blue, so then it should be X plus Y, right? So this is corresponding to it, the term is written here, X plus Y, right? Now if this three terms we get, now what we do is we write them together, okay, combine them, and combining with the help of this product. So because it is in the POS form, so we combine them. Okay, so combining them, the final answer will be look like something like this. So X plus Y, Y plus Z, and Z plus X. Okay, so this is the final simplified form, the answer in the simplified form. So this is how we simplified. And now it is although I have not included the logic diagram for this. Logic diagram means the AND or invert circuit. So I have not included that here, but you can implement it. So you try it by your own. It is very simple. So we have to use three OR gates at the first level. Okay, and then at the second level we will use AND gate with three inputs. The inputs to the AND gate will have the inputs will be this one. X plus Y is the first input, Y plus Z will be the second input to the AND gate, and the third input to the AND gate will be Z plus X. Okay, so at the first level there will be there will be three OR gates, and three OR gates with two input OR gates. Okay, I should say. And then at the second level there will be three input AND gate. Okay, so this is how you do it. Now let's see, in the previous two problems we have seen the problem without don't care. Now let us see this problem with don't care and 4 variable. Okay, so let's see. So this is the problem. So again we have to minimize this expression, which is a 4 variable expression. So you can see that it is the terms are going up to 15. So 15 is the considering both this mean terms as well as the don't care. So whenever there are don't care terms are present, we include this particular notation, D plus something. Okay, so these are the mean terms which are present plus some don't care terms. So these are called the don't care terms. Don't care terms are specified with D. In either of the if it is whether it is a SOP expression or the POS expression, in both the expression the don't care terms are shown with D. Okay, now you see, if these are including this both the groups, don't care and the mean terms, we see that what is the biggest what is the highest decimal number present in this two terms. So we can see that the 15 is the highest decimal. So 15, to include 15, we have to show we have to draw the scheme map for 4 variables. Okay, because 2 to the power 4 is 16, so 16 is greater than 15, so we have to satisfy this condition. Okay, so satisfying this, we see that we have to draw the K map of 4 variables. So the 4 variable K map will look something like this. This already we have seen the empty K map. So these are the places 0, 1, 2. So starting from the this is your MSB and this is your LSB. So A, B, C, D. So we write it like this, A, B, C, D, and then our terms become particularly we have to write. So which terms are present? So let's say the mean terms which are present will be marked as 1 in the K map, whereas this terms we will mark with cross, or we can write the don't care, D as well. Okay, so cross or don't D, or whatever symbol you choose. So basically here we have written, in this particular question we have written D, but in the next questions probably we will write X also. Okay, or maybe D, so whatever. So let's say this fourth mean term is present, so at fourth place, at this fourth cell, we will write 1. Okay, the location of this particular this fourth mean term is this, so we'll write 1 here. 5, 7, 12 are also present, so 5, 7, this is the fifth mean term, this is the seventh mean term place, then this is the 12th mean term place, 14th mean term place, and 15th mean term place. Okay, so these places are filled with 1. Okay, so no other mean term is present. So you can see in the scheme map also there is no one, means no other one. Okay, the 1 is written at this places only. Then let's see the don't care terms. So at this places 3, 8 and 10 we will put a D or cross marks or cross mark. So 3 at this third location, this cell location will mark a D. Okay, we have marked a D already here. Then I will put a D here. Okay, so this is 10. Then 8, so 8 is also here. So we have written a 8 here as well. Now let's try to group them. So let's try to form the group, and then we will see later on that how to implement the circuit for it. So the group is like, first of all we will try to form a group of 16, so not possible. So what is the highest group which we can form? So you can see that the highest group which we can form is this particularly quad. Okay, so this quad, they are adjacent cells 12, 8, 12 and 14, 10. Okay, because if you fold this K-map, if you assume that they are folded, if this K-map is folded, so as I have already, we have already discussed that the leftmost column is adjacent to the rightmost column, and also the topmost column is adjacent to the bottommost column. So you can assume it is this particular cell as, I mean, if it is folded, so it will look like a ball. Okay, so it will look like a sphere. So you assume that these all cells are there on the sphere. So this is an enclosed sphere, although we have drawn it on the 2D, but if you will consider it as folded, and if you consider its 3D diagram, then it will look like a sphere, a ball. Okay, so this, if you combine, so this will be your quad. So combining this quad, the term 12, 8 and 14 and 10. Okay, and in this terms you will see that all the in this particular group there are don't cares we are using. Okay, so don't cares are used to, here the don't cares, inclusion of the don't care in the group is actually reducing the number of variables. Okay, so it is helping in these don't cares are helping in forming a bigger group. So that is why they are included. Okay, so this is as per our rule. So that is why they are included here. Now if we write this, because this is a mean term expression and we have filled up 1 entries, so each of the terms will be the mean term. Okay, product term, not the sum term. So product term. So corresponding to this particular group, if we will see, so the term which we will get is A. So you see this. So what is changing and what is not changing? So the variables which are changing will ignore those variables, and the variables which are not changing. So if you will see this, A is not changing here. Okay, so A is remaining same, whereas A is remaining cells same in this 2 cells, whereas also in this 2 cells. Okay, if I consider this 2 particular things, so here C is 0, but C in this cell is 1. Okay, so you can check it from here, but D is 0 here as well as D is 0 here. So corresponding to it, if you will see, so the term will be A and D bar, because D is 0 and A is remaining 1. So your term is A D bar. Okay, so similarly we can form other groups, and then we can after forming the groups we can write the term corresponding to that. Now we have formed the quad, we have already formed the quad. Now we will try to form some other quads as well. So is it possible to form quads, octs? So we have already checked for octets, and we have already checked for the this whole all 16 group of all 16 terms, 16 cells. So that this octet is also not possible, and the 16 cell group is also not possible. So we ignore that. Now let's see, the pairs are also possible. but we cannot form any other quad. So quad cannot be formed now, but two pairs can be formed. So this is one pair which you can form, and this is the another pair which you can form. So corresponding to this pair, we get the term A bar, B, C bar, and corresponding to this we get the term B, C, D. Okay, so B, you also check it once again if I made any mistake. So I can see that for particularly this B is remaining same, so B will be same, and also CD. Okay, so CD is also same. So A is basically changing. So A will be ignored. A will be left out because A plus A bar will be 1. So corresponding to this we have the term BCD. Now as we get the terms, three terms BCD, A bar D plus A bar B C bar. So corresponding to this, we'll write the expression like this, okay, with sum. Okay, there is a mistake, this two sums are included, so just ignore it. So we write the terms like this, then we implement it with the AND OR invert gate. So AND OR invert gate. Okay, so you can implement it like this as well by putting a bubble at the input side. Okay, so we can enlarge the this particular slide and can see it. So there is a bubble inside. So I tried to show. I've tried to show that how you can include. If you don't include the bar, this A and A bar inputs, then you can use directly A, and also you can use a bar here, okay, a bubble. So a bubble is equivalent to the bar or the complement, so that is why. Okay, so A complement, B and C complement. So we are using two this is a 3 input gate, AND gate, and we are using two bubbles at the input on the A input and the C input, so that is why it is becoming like this, and BCD, so directly, and A D bar. Or otherwise you can include, then these three terms are ORed with a 3 input OR gate to get this particular expression, right? And then later on, you can also include it, implement the same circuit with the help of this. So this we have already discussed, that how to get the complemented and uncomplemented variable. Okay, so we got this, we have already discussed. Now after this, let's say in the question, though it is not asked that we have to implement it with the help of NAND gate, but suppose if it is asked, then how to do it? It's okay, just a minute. Okay, so we saw that how to implement it. Now let's say in this particular question, though it is not asked how to convert a given circuit to the NAND or NOR logic. So in this question particularly, we have implemented the function, whatever the minimum function we got, with the help of AND or NOT logic. But suppose we want to implement the function with the universal gates, okay, either the NAND gate or the NOR gate. Then what we do? Okay, so we can convert any AND or NOT circuit to NAND or NOR circuit. So how to do it? So this is the in the simple words I have outlined the procedure. So I won't read it out, but I'll just explain it. So what we do is it's a simple logic. I'll explain it with the help of an example. But the simple logic is, see, we know that the inverted input means inverted AND gate. So if we bubble all the inputs, and then this is an AND gate, so this will be equal to OR gate. Okay, so you see this will be equal to a A bar, so this will become A bar, B bar and C bar. So A bar, B bar, C bar, and then it is ended. So A bar dot B bar dot C bar. So if I apply the De Morgan's, then it will become A dot B bar, A plus B plus C whole bar, right? So then it will become equal to your NOR gate. Okay, so that is what I was telling. See this bubbled, not AND or invert AND is equal to NOR gate, right? So invert AND is equal to NOR gate. So if there is the logic is, wherever we have to get the function, so what we do, we use two bubbles in the input side. So wherever we have to change the circuit, we have to get the the variable, so we put two bubbles. Okay, then if two bubbles can be replaced with the help of AND gate, or you can replace it with if these two bubbles are coming in series, then they can be ignored. Okay, so you see, I'll explain this with the help of example as well. So what I wanted to tell you is the conversion procedure for any AI this AND or NOT circuit to NAND or NOR circuit is as follows. So what we do is we first draw the AND or NOT logic circuit. Okay, then once we get the AND or NOT logic circuit, then if you want to, let's say, implement the circuit with the help of NAND gate, then what we do, we add a circle at the output of each AND gate, okay, and simultaneously at the inputs of the all OR gates. So what will happen with this, that see, if we'll add two circles, so that is what I was telling you, that if we add two circles, then the output won't change, because you see, in this particular case, if you will add two circles, so the input of the OR gate will also be circled and the output of the AND gate will also be circled. So the output of the AND gate, okay, if the output of the AND gate is also circled, so this will be equivalent to your NAND gate. And if you will again consider the same logic which I was explaining with for a NAND gate, I have explained you. Similarly, the same logic will be applied for the NOR gate as well. So this we have already studied earlier. So this particular input will become your NOT OR gate, inverted bubbled OR, or bubbled OR. You can call it anything. So in the very first few slides, when I was explaining you the gates, in the second slide or third slide probably, I have listed all the gates. So there I have told you that how to do this. Okay, so what is the significance of this? So you see, this will also be equivalent to an NAND gate. So if you include two bubbles, so first draw the AND or NOT logic circuit and then include two bubbles. So one bubble you will include at the output of the AND gate and the other bubble at the input of the OR gate. So if you do this, then the circuit, whatever you can get, whatever you are going to get, will be your NAND circuit. Okay, obviously there will be some inverters, so that those inverters can be easily implemented with the help of NAND gates by just combining the two inputs. Okay, so this was the logic. This is the logic. Now similarly, if we have if you want to implement the circuit with the help of NOR gates, so again the circuit, again we will choose the same logic. We'll add two circles. The output, if OR gate is coming at the output of the OR gate, if the bubble is coming at the output of the OR gate, then it will become a NOR gate, and if the bubbles are coming at the input of the AND gate, then it will also become OR gate. Okay, NOR gate, sorry. So this is how you do, and add or subtract an inverter. Okay, so this already I have told you. And okay, if there are two consecutive bubbles, then what we do, we replace the bubbles, both the bubbles, because it is sort of double complement. So double complement if we do, then we get the same variable. So again, after all the replacements and all the things, if again we are getting two bubbles and the things are not changing, so then those two bubbles will be ignored. Okay, and if the single bubble is left out, then that single bubble is replaced by a NAND gate or a NOR gate, and that's inverted. Okay, so we have to implement a NOT gate with the help of this. So then this is what we do. Then let's try it. So let's say in the last for the last question, if you try it, so this was the expression which we got. So, and this was the last the circuit which we have seen. So now see how we do it. So for this circuit I'll explain particularly with I'll elaborate everything here. So you see, this is the circuit which we got in our last slide for the last problem. So now if we want to implement this circuit with the help of NAND gate, so then what we do, we put two bubbles in this particular. So we put a bubble here and we put a bubble here as well. So if we put two bubbles, then the circuit will be converted to this circuit. Okay, this circuit will become equivalent to this circuit. And why we are doing this? Because we know that the bubbled OR gate will be equal to NAND gate. Okay, or I have already explained this. So because this is true, then this particular gate will be equivalent to this gate. Whereas you have used two bubbles here. So two bubbles, one bubble is already included, so one bubble is shown here. So this is already this is already, I mean, a NAND gate. This already became a NAND gate, and this is also, I mean, this is also equivalent to this. So we have replaced this sign, bubbled input, with this sign. Okay, so this sign is actually coming here. So this sign is replaced with this sign. Okay, so again it is an AND gate, and at the very input you can see that these are NOT gates here. So to implement a NOT gate with the help of NAND gate, what we have to do is we have to connect both the inputs. So both the inputs are connected here simply, and it is the NOT gate is realized with the help of NAND gate here. So now you can see that in this particular circuit there is no other gate. We are not using any other gate to implement the circuit. We are just using the NAND gates to implement the complete circuit. So you see, so this proves that a NAND gate can be used to implement any circuit. Okay, so we have used NOT. Okay, we have used a NAND gate to implement a NOT gate. We have used an AND gate to implement an AND gate. We have also used an AND gate to implement an OR gate as well. Okay, so this is what we can do. Now similarly, we can implement the same circuit with the help of NOR gates also. So to implement the circuit with the help of NOR gates, what we will do, we'll replace this NOT gates. Okay, we'll implement this NOT gates with the help of NOR gates. So the same logic will connect both the inputs together. So if both the inputs are connected of NAND and NOR together, so they becomes NOT gate. So this is how we realize the NOT gate. Now this particular logic, how we can do is, we can again see that use this logic. So what we are doing, see again in this particular circuit, if we use two bubbles, okay, at the complement here if we use a bubble, and as well as here if you use a bubble, then what will happen for this bubble, okay, if I'll come to that particular, but this bubble is equivalent to what, this particular thing. So you see, or otherwise don't use a bubble here, we can convert it like this as well. See, this particular gate, this particular AND gate is equivalent to this gate. Okay, this is bubbled OR. So bubbled OR is NOR, and then this bubbled OR is equal to your NAND. So this is what we have already seen. So bubbled OR, so except this bubble, if you see, so this is NAND gate. Now if you use a bubble, it will become an AND gate. Okay, so bubbled means bubbled NOR gate is equal to your AND gate. So each AND gate will be replaced with this particular, okay, diagram. So this particular diagram, if you see, so this is coming here. So we'll replace each of this gate with this. Now at the input side, we will connect, because earlier we have connected with A bar, B and C bar. Here there will be some change. So because there are bubbles, so this is a 3 input gate, so all the inputs will be bubbled. So previously the input which was connected to A bar will be now connected to A rather. Okay, so this inputs are coming from the inputs to this NOR gate are coming from A, then B bar and C. Okay, rather than from A bar, B, C bar. Okay, so this is equivalent to this NOR gate. Okay, now we have replaced the AND gate with the help of NOR gate, and you have also changed the inputs, okay, to this. And this particular, because you see this is already an OR gate, so what we do, we just put a bubble here. So this is also an OR gate, but we want the OR gate, so what we'll do, we'll again use a NOT gate at the output. So this particular combination, this with this, will be equivalent to your OR gate. So this is how we can do it. Okay, so we have implemented the same circuit with the help of AND, OR and NOT logic, and OR and NOT logic, and also with the help of NAND gates, and also with the help of NOR gates. So this proves that our NAND gate and our NOR gate both are universal gates, and any circuit can be implemented with the help of NAND, NOR circuits as well, NAND and NOR gates as well. Okay, so the logic is, I think, clear to you. Obviously you can ask the things in the doubt class also. So we'll clarify if there is any doubt, if still there is any doubt is remaining, so we'll clarify that in the doubt clearing class, okay, or the tutorial class. Now let's try another problem. So in this problem we have to minimize this expression, and this expression is again the same type of question which we have done earlier. So this is again a 4 variable expression. Okay, the maximum term which is coming here is 15. Okay, so if you check it, so 4 variables will be required, although they are given here, listed here, f. Okay, this is like wrong, this should not be there. but you correct it. Okay, so f is a function of a, b, c, d, and the terms are this. So according to this, whatever terms are given here, fill up the entries in the K-map, and then so you see we have filled 1 here at this location. Then for at the 4th location, the location of the 4th mean term is also filled with 1. Then d is filled here. Okay, first let us fill the terms, mean terms, and then we'll come to the don't care. So 1, 4, 7 and 10 and 13. So these places are filled with 1. Okay, then the other places 5, 14 and 15. So 5, 14 and 15, they are filled with D or cross. Okay, so D have filled with them this particular places with D. Now let's try to form the group. So as you can see, we cannot form a group of 16 cells, so just ignore it, then come to the lower one. So can we form the octet? So still you can see that we cannot form an octet. So octet is also not a possibility here in this particular question. So come back to the lower group. So now let's try to form the group of a quad or a group of 4 cells. So can we form a group of 4 cells? There can be multiple groups as well, okay, but we can see that there is only one group, and in that particular group 2 don't cares should be included. If these 2 don't cares are not there, then we cannot form any group. Okay, we cannot form any quad. Okay, so as 2 don't cares are there, then this can be formed, this group can be formed, this squad can be formed. So this squad, because you can see that why we have included this don't cares, because this don't cares are helping us to reduce the expression. Okay, that is why the number of variables are reduced because of this don't cares. So those don't cares are used if they are, if they are used to form the group, then they are considered as one. Okay, so to consider, when we consider them as one, so our quad is the term corresponding to this squad will be BD. Okay, the same logic I have already explained you. So why we are getting this BD, so you know it. Okay, BD. Now corresponding to this, then we can form the other pairs. So you can form this pair, so there is no other possibility. So this pair, then this pair, and you can see this D is overlapping. Okay, so D is used not only in this group, but it is used in this group as well as in this pair as well. And you can, that is what was one of the rule was that you can use a particular term multiple times if it is useful in reducing the expression. So you can see this D is useful in reducing this expression. It is helpful in forming the pairs. So that is why this D is used here. Okay, multiple times in the multiple groups you can see. Okay, so this is these are the 2 pairs, and then you can see that one more pair we can form. So one more pair, this particular pair, one more pair we have formed. So all the don't cares are although used in this question, and no don't care is left out. So no need to worry about that. If any don't care is still left out and it is not used in forming a group, no need to worry about it. You just leave it like that only. But here in this case we can see that all of them are included, and corresponding to these terms, this particular groups, each of them, the terms are also written here. If we include all these terms and write the expression together in the sum of product form, then the expression will look something like this, right? So this expression we have implemented with this particular and or not logic. So bubbles are used here. You can magnify it and see that at the inputs I have used bubbles, okay, to implement the logic. So this is how we implement it. Now convert the same logic. You try it out, okay, by your own, that how to implement the same logic with NAND and NOR logic. So although I'll show you it here, but you can try by your own. So you can see directly that this is the other way we can implement it. Then we have implemented it with the help of NAND circuit, NAND only circuit, and also the NOR only circuit, okay, using the same logic. There is no change. To get this circuit from this, we have used 2 bubbles. So one bubble here and the another bubble here. Then whatever, because all the inputs of this OR gate will be bubbled, then this can be replaced with a NAND gate, because this is equivalent to, and this will become equivalent to NAND gate. So we have to do this, okay. Then to implement this circuit with the help of NOR gates, what we will do is we will replace this gates, okay, as seen in the last slide, last question, we'll replace this with this, okay, NOR gates, and then we'll use this particular two bubbles here. So this is what we do. So the same circuit can be implemented with in different forms with universal gates as well. Now let's understand the problem for a 5 variable map. So a 5 variable map is not difficult, but it is little tricky to understand. So we'll understand the question with the help of we understand this 5 variable problem with the help of a question. So this question contains these terms and it has certain don't cares as well. In this question I have marked the don't cares with D, okay, in the cross, with the cross. So to make a 32, because you see 2 to the power 5, because there are 5 variables are involved, you can see that the highest term which is available here is 31, okay, and it is a 5 variable expression. So you can otherwise, anyway you can see that it is a 5 variable function. So 5 variable function will have 2 to the power 5 cells. So 2 to the power 5 cells, can draw it. How we can draw 2 to the power 5 cells? We draw it in this form. So this is one square containing 16 cells and there is another square which is containing 16 cells. So two separate groups we have formed. Okay, so in this group particularly A will be considered 0. Okay, in this particular cell or in this particular square of 16 cells, A will be considered 0. Whereas in this particular cell, A will be considered 1. And when we have to see whether this two particular, which cells are adjacent to, how we'll check the adjacency. So to check the adjacency, we just overlap this group, this particular cell, this particular square over this. So if you just superimpose this square over this or this square over this, then whatever cells are coming adjacent to each other will be called adjacent cells. Okay, so this is what the logic is. So you see, so you got it. So you have to superimpose one over the other. So take one, pick it up from the page, let's say, and replace over it. Okay, so put it, just imagine that you have picked it up, this one of the square, and superimposed it over the other one. Okay, so if you do this, then we can see that we can form this particular one octet. So there will be one octet. So what is that octet? So see, this red and this particular red, this is forming an octet. Okay, in this octet we have used a don't care as well. Okay, so first of all we have filled these entries. So the places of the entries are 0, 1, 2, 3, 4, 5. So these places are same as the 4 variable K map. Okay, and here also these places are same. So we have used, see, A is 0 here, B, C, D, E. Again A is equal to 1 for this case and B, C, D, E. So order is same. Just what we have done is we have used the mean terms. This particular square is for mean term from 0 to 15. Okay, so 16, this is for the first 16 mean terms. Then for the next 16 mean terms, the squares are something like this. So 16, 17, 18 and 19, 20, 21, 22 and 23. So the order is same. Okay, then 24, 25, 26, 27, 28, 29, 30, 31. Okay, so no need to get confused. Okay, so now we fill up the entries and you see that this filling up the entries here, whatever terms are available. So 6, 9, okay, we have filled 6, 9, then 13, then 11 is not given here. Oh, sorry, 15. Okay, 15 is marked 1. Okay, there is a mistake here in this question, I think then. Okay, anyways, so probably I have made a mistake while marking this particular things. How it got like this, I don't know. Okay, so we'll see this problem in our tutorial class, because there is a mistake in this question. I can see that I should have marked 6, then 9, so 9 is 1, then 13. So 13 is although marked 1, then 18. So 18 is also marked 1, then 19. So 19 is also marked 1, 25. 25 is, where is 25? This. Then 27, then 29, then 31. So up till here things are okay, but then 2, 3. So 2, 3 are marked cross, then 11. So 11 is also marked cross, then 15. So 15 should have been marked cross, but I have marked it as 1. So it is a mistake. Okay. So then 17. 17 is also marked as cross. So no problem. 24. 24 is marked as cross. No problem. 28. 28 is also marked as cross. So there is one mistake. Okay. Not many. So either ways this is included in the term. So rather we'll see it here itself, because this is included here itself. So we'll consider it as 1, or you can consider it as a cross as well. Okay. So the answer will be correct in either of the case. So you see, corresponding to this we can consider. So this is an octet. Okay. So this, if I superimpose this square, if I superimpose this square over this, then you can see that this cell will be just fall over this cell. So cell number 13 will fall over the cell 29, and cell 15 will fall over the cell 31. Cell 9 will fall over cell 25, and cell 11 will fall over cell 27. So they are adjacent cells to each other. Okay. So if they are adjacent cells, then we can form a group, and that will be an octet. Okay. So this corresponding to this octet, if we have to find the term, then again the logic will be same. We will replace the variable which is changing. Okay, we will ignore the variable which is changing, but we will include all those variables which are not changing in the answer term. So you see how we do it. So to do it, see this, and this for corresponding to this particular red group, you will see that A is changing. Okay, so A is 0 and A is 1 here. So A will not come. Okay, obviously that is for sure. Now let us say B is same. Okay, so B is, see, for this particular whole octet, if I consider together, so B is remaining 1. Okay, so B will be same. C is changing, so she should not come here. Okay, so C will not come here. So B is one variable, and it is uncomplemented. It will come in the uncomplemented form. Then what about D and E? So let's see, D is also changing. So you can see for this particular cells, D is changing, but E is not changing. Okay, E is remaining same for this, as well as it is remaining same here as well as here. So E. So corresponding to this octet, the term which we get is BE. So this is what is written here. So the red, for the red color group, the term is also written with red color. Okay, so that is just to explain you the things clearly. Then is there any other possibility? So we can see that if we we can form another octet. Okay, sorry, not octet. There is not a possibility to form, there is no other possibility to form an octet. So we'll check for quad. So quad. So you can see that 3, again the superimposition of this particular square over this we have to consider always. So if you superimpose this with this, then we can see that 3 is superimposing over 9 and 2 is superimposing over 18. So this particular, these two ones, 18, 19 and 2, 3 will form a octet. Okay, sorry, will form a quad. So this quad, corresponding to this quad, if we have to find the term, then again we have to use the same logic. So corresponding to this, the terms will be B bar, C bar, and A is changing. Okay, so whenever you are forming a group which is having some cells from this particular square and some cells from this square, so obviously A will not come because A will change. Okay, C, so A is not going to come, whereas B bar, C bar will come. And then what about DE? So E is changing. Okay, so E is becoming 1 here and 0 here. So E is changing, so E will not come in the answer. Then the term is D. So D. So you see, the corresponding to this particular octet, this particular quad, the term which we will get is B bar, C bar, D. So see this, B bar, C bar, D. Okay. Similarly, can we form any other octet quad? So no, it's not possible to form. If you check all the adjacencies, then you will see that there is no other possibility to form any quad. So we won't form any quad again. Now let's try to form the pair. So still there is one is remaining. Okay, so to include that, we can form this particular pair. So if you form a pair, then obviously you can see in this particular pair A will be there. because A is remaining same in this particular all these cells, okay, all is this particular square. So A will come, and then the terms which are not changing is A bar, then B bar, then here D, E bar, okay. So corresponding to this green particular circle, if you see, the term is this A bar, B bar, D, E bar, okay. So now we have formed, as we got 3 groups, so corresponding to each of this group we got a term, okay. So this is how we do it, and so this is how we have done it, and we have not implemented the question in the AND or NOT logic or NAND or NOR logic, but you understood the procedure, so you can use the same procedure to implement the function. If you have any doubt, you can ask me it in the tutorial class. Now this last question, so in this last question, is there any other question? Okay, so last question. So this last question we will implement the same thing in the POS form, same type of question, 5 variable K-map in POS form. So in the last question we have seen it in the SOP form. In this question we will see it in the POS form with don't care. So the don't care terms, these are the all don't care terms, and you can see that the highest term which you have is up to 30. So you will require 5 variables, okay. So 5 variable K-map is drawn here. Then to show these terms, we have to fill up the entries with 0. So you can check it if there is if I have filled them up correctly, then you can solve it directly here, and if you find any mistake, you just point me out there in the class, okay, tutorial class. So let me check it once. So 0 1 0 1, then 4, then 7 8 8, where is 8? So 8 is this 0, then 10 0, 12 is this 0, then 16, so 16 is here 0, 20 is here 0, 21 is 0, 22 is 0, 23 is 0, 26 is 0, then 30, so 30 is also 0, right? Then because you see this is a product of sum expression, so product of sum expressions we have to fill zeros here, okay, in the K-map. Then 2, so 2 should be marked with cross, so 2 3 11 is, where is 11? 11 is here, so this is your 11. Then 15 cross, then 17 will come here, 17, then 24 is here, so 24, and 28, so 28 is also marked cross. So you can see that all the squares are marked correctly. Now if they are marked correctly, then we can by superimposing one over the other, one square over the another square, we can see that what are the adjacent cells. So we can see that this particular red cell is adjacent to this cell, okay. So this left column is adjacent to this left column, okay. So this is an octet we are able to form. So this octet will have, corresponding to this octet, if you will see the term, so the term which we will get is D plus E, okay. So D plus E term we are getting, you can verify it. So because in the POS form the zeros are denoted by non-complemented variables, okay. So this D, and it is also denoted by the plus term, okay. So DE. Other terms, other variables A, B, E, A is changing because you are taking one group, one quad from this and the another quad from this to form the complete octet. So A is changing, A should not come. Then otherwise B and C are also changing, so the terms D and E are not changing. So the term corresponding to it will be D plus E. Similarly, is there any other possibility to form a quad? So you can see that we can form a quad with this particular terms. So corresponding to this cell, this 4 are coming together, 12, 8, 28, 24. So this is one quad, and the another quad is 14, 10, 30, 26. So this is another quad. So this complete, if you and these two quads are adjacent to each other. If you fold them up, you'll see that they are adjacent to each other because overlapping one over the other and then folding it up, okay. So what you are doing is you are taking one square, overlapping it with the another square, and then folding them up. So this is how you are doing it, okay. So folding them up completely. So if you do this, then your whole thing will be, again there will be two terms, okay. The function, the term will have two variables. So this particular will also have 2 variables. So corresponding to this, if you will see, B is not changing. So B and E is also not changing. So the variable will be B bar because B is 1 and E. So B bar E. So corresponding to this, we are getting this term. Now is there any other possibility to form any octet? So you can see that there is no other octet which you can form. Now let's see any other quad. So this quad is possible. So this quad is possible. So we will form this quad, and we'll see that is there any overlap possibility. So no overlap possibility. So this quad. So corresponding to this quad, because you see 1 0 is coming here when 1 cross is coming. So as I have already told you, this is a don't care, and don't care can be considered as 0 or 1. So again this don't care, we consider it as 0 because it is used to simplify the expression. So this is what we get, and we include it here. So corresponding to this, the term is, you see, B is not changing, so the term will have B. Okay, then you can see C is changing, so C will be replaced, and A, so A will be there. Okay, then it is D. So D is changing, so D will be ignored. Then E. So the expression for this particular term will be B, then A, B and E bar. Okay, so A plus B plus E bar. So this is what the term we are getting corresponding to this. Okay, similarly, is there any other possibility to form any other square or any other octet or quad? So you can see there is one more possibility to form this quad, but we will not form this quad. Why? Because in this quad, this two terms, this particular 0 is already used, and this is, I mean, although this because you see, if this is already used and it has been formed a group, so there is no new term, no new max term, or no new max term will be used in this particular new group. Okay, so that is why we won't form any new group. We won't use unnecessarily the don't care. Okay, don't care terms. The don't care terms should only be used if don't care, at least one term should be a max term or mean term when we use the don't cares. Okay, so we can see that there is this group is not possible. So there is one more possibility. So we have not formed this group. So this zeros. Okay, so these zeros are remaining. So corresponding to this, we get another term. So this term is A bar. For this particular cell, the term is A bar. A is 1, so A bar. Then B, C bar. Okay, so this is what we are getting. So this is how we get the expression for 5 variable K-map, and you can implement the function as it was the combination of max terms. So we have used the product term in between. Okay, so this is how we have used the K-map to simplify the variables up to 5 variables. So we have seen the examples for 3 variable K-map, for 4 variable K-map, and for the 5 variable K-map, and we have seen it with and without don't care. Okay, so by just following the rules, you can solve any problem. So try some problems by your own, and if come up with some problems, and we will solve them in our tutorial class. So I'll end this part here itself because it is getting very long. It became very long. So okay, thank you for listening, and the last part of this particular lecture I'll consider in the next part. The tabulation method or the Quinn-McCloskip method will consider in the next part. Thank you for listening.